broadcasting from my basement. So we're going to try a couple of different things. This is the first lecture that you should be watching. This is for Monday, and that would be March 16th. So here we go. If you start to look at the PowerPoint slides that I've done for today's lecture, we're going to talk more about structs. And now, structs are a building block, they're a container. And those structs allow us to put things into the container that we need, or that is important for us. So if you think about it, you have a box, and that box has a name. We looked at a box that had the name of person, okay? Now today, what I'm going to do is I'm going to take this box and I'm going to expand upon it just a little bit. And what I'm looking at is doing something that we call a linked list. And so you've got some slides that I've already showed you and that I've posted that have linked lists in them. Okay, a linked list is a pretty simple idea. There's some application data, whatever that data is in here, and then there's a link that takes you to the next item in the list. And that link takes you to something that's formatted exactly the same. Okay? And these are of the same type. And in this case, we're going to call these, and I've got to write larger because this is low resolution video. These are both of type linked list node. Okay? And so we're going to create that. We're going to run a couple of example programs here to show you that. Okay? Now, you should start the PowerPoint slides now, and we'll start talking about what's in the PowerPoint slide. So you notice the first one is labeled COVID-19 lectures. All of these I'm going to post on Moodle are going to have some name like COVID-19 lecture number 1, number 2. We're going to be doing this for several weeks, and so we really have to stay organized and stay engaged in order to make sure that we do what we need to do. Okay? So, if at some point you don't understand something, or at some point you're like, what the heck was that? What you really want to do is stop, pause the video, go back, look at what was being said or what was being done. Okay? That a chance to rewind and replay the lecture is something you don't get in class. This is actually an advantage of having these lectures video recorded. Okay? Now, I'll start with a little bit of COVID data just like we did last week during our lectures. So there's a lot more to social distancing than just staying 6 feet away. Don't gather in groups, okay? This is the thing, right? You don't want to transmit. Community transmission or community infection is what we're trying to limit. The reason we're trying to limit this is because we don't want to spike above the capacity of our hospitals. That's what Italy did, and they're still in bad shape. Okay? So that's why we're canceling all sorts of in-person and group activities. That's why we're going to online lectures. Now, on a personal note, an initial study of people diagnosed with COVID-19 and confirmed included about 55,000 people. This initial study, they broke them down by what's called comorbidity, which are confounding factors or extra factors. The highest factor, as far as death rate was concerned, was those people in that 5,500 who had cardiovascular disease. And those people in the 5,500 that had cardiovascular disease died at 13 times, if I remember correctly, the rate of the average in that group. Diabetics were second. In fact, diabetics died at a rate, so all the diabetics in this big group, you know, you got the big group, you go down to just the diabetics, you look at the death rate in there, and the death rate in there was 9.2%, i.e. 1 out of every 10 diabetics that contracted corona in the first month died. I'm a diabetic. That's why I'm here in my basement and not on campus, just so we understand. Okay. Now these containers, let's go on with the topic at hand, C++. These containers in C++, these structs, are primitive. Okay. All they contain are data members. And so we're going to start using the terminology data member versus functional members. Data members are things that are actually holding data. And so the only thing in these structs are data members. You can't have anything other than just data. When we get to classes, they'll include functional members, i.e. they'll include code that goes along with the data. Now, all structs are defined the same way. They have a keyword. They start with a keyword called struct. So, let's take a look at that. Okay, so you get the keyword struct. And then you get a name. And the name is something you pick. In this case, I'm going to pick linked list node. And we've talked a little bit about linked lists, but we're going to take a deeper dive into what that linked list node actually is. Okay? Now, inside, we can put in data members. That is, things that look like variables, things that are defined very similar to variables, and they'll be pieces of the container that can hold information. So for instance, we'll have an int ID, okay? And then I might have a double called readings. Whoop. Called readings. And I'm going to make that an array, and I'm going to have it, actually, I want to make this generic. I don't want magic numbers in there, so I'm going to say max readings. Again, just getting used to lecturing, writing on a whiteboard, which I haven't done in years. And then a semicolon out here to end it. Okay, so we've got an array. I'm going to add a couple more doubles. And let me make sure that that's exactly what I want, because I've already written this code and it's on my laptop. So, where are we? Sensor. Yep, those are doubles. And so I just have lat and lon, okay? That's going to be latitude and longitude. And so what we've got here is actually for sensor network nodes. I've done some sensor network research, so I usually pull my programs from work that I've done in the past or things that I find interesting. So I've got a sensor ID, and this might be an ID for the network. I have a double, which is the last 5 readings. So we're going to have a sliding window. We're going to think about this as, what are the last 5 readings from this sensor? It might be temperature, it might be wave height, it might be wind speed, it might be light. Who knows? Who cares? Nobody cares. I have a latitude and a longitude. That is the location of the sensor out in the world. So maybe we go through the woods and we're leaving these sensors here, there, everywhere. Okay? But we don't know how many sensors there are going to be. This isn't something that we can decide ahead of time. oh, I'm only going to have 6 sensors. Well, over time that's going to scale, and over time there's probably going to be more than any guess you have. So we're going to store this in a linked list. And the linked list part of this is a pointer. The pointer, okay, is the thing that's going to make the links. I draw them as arrows in the diagram. Those arrows are essentially addresses, memory addresses. And so I need something that can hold a memory address, but what does it need to point to? It needs to point to one of these things. And so I can already use this as a type right here, inside of the same struct that I'm defining. So I can use this even though I haven't completely defined it yet. And the only way that you want to use this inside of itself is as a pointer. So we're going to do star next. That's a pointer to the next node. It's just an address. Its type is one of these containers, and it's going to store the address of the next one in line. And then we shut that off. Okay? And now I'm going to take just a little break to make sure that the video that I'm recording is actually recording well. Okay, and we're back, and I need to adjust the camera so I can see the preview of the screen, make sure I'm in frame correctly. So I've adjusted the camera a little bit. Probably that first video segment, which will be lecture 1, part 1, my voice is a little quiet. And it's because I think the camera was so far away, so I've moved it up closer, I've zoomed it in. You can probably see the board a little better. I'm going to shut off the light that I'm using to highlight the board and see if that works a little better for you. So, I had written this struct on the board. This is the struct for a linked list node. I've got that code in the slides as well, and what I would like you to do right now is to pause the video and then use the slides to create 2 files on either on Colossus or on your local machine if you've got G++ on your local machine. And those files are going to be called sensor.h. That's going to include this with a couple other lines of code, and ex1.cpp for example1.cpp. Now, when I run this code, okay, we're going to end up with just a real simple program that's going to populate a local variable of this type, okay, called temp, and that local variable is going to hold the data for a single sensor node. It's just some dummy test data to make sure that we can read and write the data for one of these things. So when you get that typed in, then unpause the video and we'll continue on. So now we're continuing on. That code had everything dumped into main, and that's not a very modular way of doing things, and that's not how we're going to do things from this point on. So what I'm going to ask you to do right now is to take the second slide of the program. So ex1.cpp, okay? The first slide of that program has the include files, it has the using namespace standard, and it has the top of int main, okay? Well, what I'd like you to do is to go to the second page of ex1.cpp and copy out that code that says initialize some test data right at the top. And I want you to copy that code, or actually remove that code from that part. So I'm doing it right now on the screen. So I'm going to edit my ex1.cpp, okay? And I'm going to delete that initialization code out of my program, out of main. And what I'm really doing is I'm going to move that into a function, and that function is going to be called read data, okay? So let's see, how many lines of code is this? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 lines of code, but a couple of those lines of code we're probably going to get rid of. Okay? So I'm going to take out those 13 lines of code. I'm going to go up above main because I prefer to put my function definitions above main. And I'm going to put in a new function. This function actually is going to be a void. I really don't have anything to return from the function. Okay? And it's going to be called read sensor data. READ, capital S, sensor, capital D, data. And it's going to take a single parameter. And that single parameter is going to be one of these type defs, a variable that is of this type. Okay? And what that actually is, we're going to leave for just a bit. Okay? So the way that we're going to pass this in. Okay. The worst color to use on a whiteboard, black. I'm going to switch colors here. With it zoomed in a little bit more, I think it's probably easier for you to see what I'm writing up here. So I'm going to create this function as a void, okay? And I'm going to call it read sensor data. And then right in here, I'm going to have something that's of linked list node type. So that's linked list node. Okay, and then I'm going to drop this down right here because I need the name of that. What am I going to name that local parameter that's going to exist in my function? And I'm just going to call it for now the sensor. Okay? And what I'm avoiding right now goes right here. This will eventually become a pointer to one of these things, not just one of these things. Okay? So when we start building a linked list, we're going to have a node and then points to, and then a node and points to. And we want to be able to populate that from a function that works with those linked list nodes. And this is what in classes, when we get to classes and objects, this is something that we call a functional member. But right now the structs don't have functional members, and so we can't put this code or associate this code with the struct other than it working on the struct right here. Okay? And then I'm going to close that off, and then I'm going to start with the code right in here. Code from ex1.cpp. Okay? And we're going to write this as ex2.cpp. So I'm just going to create this from that initial ex1.cpp code that you have. So you should have typed that in already, you should have compiled it, ran it, saw what was going on there. Okay? So now, I've copied that data out, I've got a linked list node as my parameter. I'm going to call that the sensor. I could have just as easily called it a sensor. Okay, and since this has no return value, it's a void, we don't have to worry about anything other than putting a return down at the bottom. Nothing gets returned, you just have return colon, that's it. Okay? And all the rest of that code in there is going to stay the same, except for the temp.id. Okay? So if you take that code that was in EX1, we're going to take all the temps and we're going to rename them as the sensor. Okay? So in that code, right here, that code from ex1.cpp, we want to take every temp and make, I'm still having problems with getting ahead of what I'm saying. So take every temp and make it the sensor. Okay? So we're just going to edit that file or edit that code that we've put into that function, and we're going to call everything that's temp the sensor. Okay? So if I'm in here in my file, I just need to grab the sensor, and then I'll be pasting it in all over the place. No! There we go. Bad copy and paste. So that first line of code is going to be the sensor.id equals 42. We're going to change that. And we're going to put in a prompt. So cout which just asks the question, what is the sensor ID? Question mark, space, close off the string, semicolon. So cout, stream insertion operator, what is the sensor ID, question mark, space, and then a semicolon. Okay, and then I'm going to read in from cin that sensor ID. So cin the sensor.id. Okay? We're still going to leave the sensor.next is equal to null. Okay, changing that temp to the sensor. And then we're going to leave the prompt that says enter the last 5 readings for sensor and then the sensor ID number. And actually we really don't need to do that, but I'm still going to leave it in there so that it's the editing that we're doing is minimal. Okay? Then for I equals 0, I less than max readings, I plus plus, cin, the sensor dot readings, and then cout sensor ID, okay, the sensor dot ID is longitude, and then we're going to cin the sensor again, and then this again temp.id in the next line gets changed to the sensor, and then temp ID in the last line gets set to the sensor. Okay, and then we just have our final line that we're adding, and that's the return. So now what I've done is I've taken that code that was in main and I've created a function out of it. And that function's called read sensor data. Okay? Now I can actually just call the function passing in temp, and that will allow me to read in the data. Okay? And so all I'm going to do is say read sensor data, and I'm going to pass in temp for right now. Okay, that should all work. I'm going to GCC or G++ this. Okay, and there's one more line of code I need to put into that function, and that is right at the top of the function. I need a local variable called I that's of integer, so int I. Okay, I need that local variable simply because there's that loop that I copy or cut out of main and put up in the function. Okay, so let's see. That looks good. And that works. Okay. Now, I think I said earlier that we were going to make an ex2.cpp, but this is still ex1.cpp. I just want you to make functions in there, get it working, and then we'll move on to ex2.cpp, where we're actually going to start building a linked list piece by piece. Okay. Now, okay, my ex1.cpp compiles, that's fine. Now I'm going to edit that again. And this time, I'm going to swing you around so that you can see what I'm doing here on screen. This is probably going to freak out because of the refresh rate on the screen, but we'll see. Okay, that's just a failed attempt. That's not going to work at all for me. Probably should just edit that out, but, you know, not necessarily. Okay. So, problem here is I really can't get a good shot of the screen, and I don't have screen capture software installed yet on my laptop. So this one's just going to be a problem, okay? I'm going to walk you through audio wise so that you can hear what I'm doing. So I'm editing ex1.cpp again, and this time I'm going to take what's on the next slide of data in the PowerPoint slide. So the first or the second slide, not data, the second slide of code, I created a function for reading data. Okay? Then on the third slide of code labeled ex1.cpp is most of the data for dumping, or all the data for dumping out a node, but it also has the all done for now return 0 at the bottom. We're going to leave the all done for now return 0 in our program, okay? But I'm going to take the rest, okay, starting right at the comment dump the test data. I'm going to leave the two new lines in main, but the rest I'm going to grab and put into a new function that's called dump sensor data. Now I could call it print sensor data, I could call it any number of things. I kind of like read sensor data and dump sensor data, so that's what I'm going to name it. So let's see, how many lines of code do I have here? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lines of code. So I'm going to grab those 9 lines of code. Okay. I'm going to scroll up above main again, because that's where I like to define my functions. Again, it's going to be a void function called dump sensor data. Again, I'm just going to use a linked list node as the parameter, and I'm going to call it the sensor, the same way I did in read sensor data. I like that name, why not use it? Okay. Now, I put in all of that code that was down in main. Makes things nice and clean. Okay. Now again, this code from main is using temp as the variable name, and it uses an integer I. So both of those I have to take care of. Okay. So if I go up here, there. Okay. I'm going to go up to the top of the definition of this function, and I'm going to put in that int I that I need, and then in the rest of the code I'm going to change temp to be the sensor. Now this is back to scoping, okay? The sensor only exists inside of this function while the function is running. It doesn't exist out in main. Temp only exists in main and doesn't exist in these functions. Okay? Remember, it's like a pigeonhole that we pass notes through. That's how the parameters work. Okay? So all of the data in temp, when we pass it into the function, when we call the function using that, all of that data is going to get copied into the local parameter in the function. Okay? And so I'm changing temp to be the sensor on each one of those. And that should be it. I'm going to get out of here, and I'm going to recompile and see if it compiles. And it does! Yay! Okay, so now when I run it, stupid Avast. Just run the program. What is the sensor ID? So now I'm getting a prompt for the sensor ID. I'm going to put in 42, because why not? Temperature, I'm considering these to be temperature readings. So I'm going to start with 23.4, and then it moves up a little bit to like 27.6, and then 32.5, and then 33.1, and then it starts dropping again, 29.8. And so that's my 5 readings. It asks for the longitude. The longitude is going to be 87.3254 degrees of longitude, and latitude is going to be 47. I don't know, 8721. Okay? There. Everything read in. Everything looked right. Except for one thing. I forgot to put in the call in main to dump the sensor data after the cout with the 2 new lines. So now I go in and do dump sensor data in main. So I'm calling the function in main, and I'm passing in temp. And now I recompile and rerun. And again, I've got to wait for Avast. Okay. Now the thing is, these videos are huge. I've been uploading the first part of the first video. Needs to finish processing before your video is private on YouTube. So it's still processing. Okay. So I go back to my test code here. I'm running my test program. I've got longitude. I've got latitude. Whoa, That was interesting. Huh. So if you remember, at some point, I had talked about oh, I know what this is. Okay, so at this point, what I did in read sensor data was I made that that function void, and I passed in linked list node, but I passed it in as just a node, which meant right here, that I altered the local copy in the code down here, but that didn't change temp out in main. So I've got garbage right now coming out. So there's a simple way to do this, and if you'll pause your video right now, well, actually don't pause your video right now. I think I've got it squared away already. So there is something called ref parms in C++. And reference parameters use or reuse one of the operators for pointers. And I just created a ref parm, and I'm going to test that real quick. So wait just a second for me. This shouldn't take long at all. And then I'll show you on the board what you need to do to this linked list node to make it a ref parm. And notice I've got that little line right there. That was like my subconscious telling me, you got something else to do here. You need to show what it is. Okay? So I'm back to putting in all those sensors, the longitude, whoops, the latitude, and that worked. Okay, everything worked fine. So the little piece that I needed, the little piece right here, for a variable, not for a dynamically but a allocated node, but a statically allocated node out in main, what I need right here is an ampersand. And that creates what we call a ref parameter, and that ref parameter can then be altered in the function, and whatever was passed in out in main, or whoever called this, it will receive the changes. So there we go. Okay, that's all working. I'm going to upload the altered ex1.cpp up to, actually nah, I'm just going to put it in my PowerPoint slides. So if you move on, you'll see the altered code in the next few PowerPoint slides, and you can do those changes on Colossus. So with that, I'm going to stop this part of the video, and it'll be another chunk that I'll upload.